On this episode of The Wretched Wrench, we have a goober that talks for way too long, but don't skip by him because he's talking about how the salespeople can win a Fisher camcorder. Ooh, that was a big deal in '85. Then we go to the GM Proving Ground so we can beat a Cadillac like a stepchild. If you find this content extremely boring and drab, well, hit the like button and subscribe anyway. And thanks for watching.
This is
Guys, thanks for watching.
the General Motors
Please leave a
Ground in
comment.
Milford,
Let me know what you think about it.
You'll enjoy this Cadillac Roundtable meeting, the fifth in our 1985 Roundtable series, because you're going to get a behind-the-scenes look at the tough real-world test program for new Cadillac models. First, though, don't forget about the opportunities you have to be awarded a Fisher video cassette recorder. Including this meeting, you'll still have 4 more opportunities to enter the drawings. And those drawings are confined to your zone. So the potential for winning is good. All it takes to be eligible is to fill out the feedback card with the 3 questions answered correctly and mail it to program headquarters within 30 days of the dates printed on the card. We really need your input to help make future meetings even more interesting. That's why we also have the Roundtable toll-free 800 number for you to call if you'd like to make additional comments regarding these meetings. We believe attendance at the Roundtable meetings is important because you become more aware of the significant role played by technicians in all kinds of businesses, including your dealership. You also have the opportunity to see and hear other professional technicians as they discuss their approach to their work, how they handle their day-to-day problems and challenges. They have the same goal you do: satisfy the customer. In your case, the customer is the Cadillac owner, and he depends upon your professionalism to maintain the quality and performance characteristics of that car. It's quite a responsibility. So is the testing of new Cadillac models at the Proving Ground. Automotive technicians like yourself play a big part in that test program. And I feel sure you'll be impressed with the time and effort and professionalism that goes into qualifying every new Cadillac model before it is introduced to the public. Most of the testing is done here at the Milford, Michigan Proving Ground, located about 30 miles north of Detroit. First established by Alfred P. Sloan in the 1920s, it now covers about 6 square miles and contains 128 miles of test roads. Testing goes on 24 hours a day, 7 days a week, year in, year out, summer and winter, rain, snow, or sunshine, with only 1 day off a year, Christmas Day. The major durability test schedule is designed to subject a Cadillac to treatment and environmental conditions much more severe than it might experience with the most demanding customers. The test simulates 10 years and 100,000 miles of operation in about 18 months. Look familiar? It should. It's similar to the service area you work in. This is where Cadillac testing is supported. part of the permanent test facility here at the General Motors Proving Ground. 80 people are assigned to the operation, including 24 technicians who function in teams, 12 as hands-on technicians, and the other half as diagnosticians and liaison with product engineers and suppliers similar to service advisors. 35 test drivers, plus administrative personnel and supervisors, complete the group. Right now, cars in the durability test program include 87 models, the new 86 Eldorados and Sevilles, and other 86 Cadillacs that incorporate changes to the 1985 models, about 25 cars in total. Testing for the new model usually begins with hand-built parts and components fitted into a modified current production Cadillac. For example, a complete 86 Eldorado rear suspension system was installed in an 85 front-wheel drive DeVille with the floor pan modified to accept the new suspension system. That was over 3 years ago, and hundreds of thousands of miles of durability testing. Next came the hand-built vehicles, then prototypes and pilots, followed by production Eldorados and Sevilles, all of them subjected to the durability test schedules. With the increased emphasis on electrical and electronic systems for 1986, test drivers are responsible for performing a daily 10-minute function test to assure proper operation of all electronic and electrical systems. This test has come to be known as an EE test. This is prior to going out on an assigned driving schedule. Test drivers receive extensive hands-on and classroom training on driving the various durability test schedules and are reviewed annually for knowing and adhering to the schedules. On new programs, such as this EE procedure, they must attend special orientation programs. Since 1973, a total of 200 owners of current model General Motors vehicles have agreed to have their cars instrumented, and more than 40 million vehicle miles of data have been recorded. This data forms the base for the development of durability tests that are performed at the proving ground to simulate the real world of customer driving. Cadillac test vehicles are exposed to a harsh corrosion environment, up to the equivalent of 10 years of severe corrosive treatment. Bare steel coupons are removed at various stages of the car's test schedule, and technicians measure the rate of deterioration without paint protection as compared to the painted surfaces. To accelerate corrosion, there's a salt spray facility to simulate road splash from other vehicles, and a salt splash facility for the vehicle underbody. These two facilities speed up corrosion to the point where 1 year can be generated in 10 days. A mud trough throws mud up into the cracks and crevices, sealing the salt water and moisture in, giving corrosion every possible chance to develop during the months of testing. All accelerations in the durability test schedule are specified: light, moderate, hard, wide open throttle, as displayed by an accelerometer. The precise speeds and maneuvers specified in the driving procedures require a high level of professionalism from test drivers. There's only one speed or maneuver that's correct to accurately simulate the electronic data gathered from the real world, and the proving ground drivers deliver that accuracy and consistency. Throughout the durability schedule, manual downshifts to both first and second gear, including downhill overruns to a maximum 45 miles per hour, provide engine braking. Second gear downshifts alone total 3,020. Potholes are integrated into several test roads, with potholes of varying degrees of severity hit over 700 total times at various speeds. The Belgian blocks generate a much higher number of low to medium inputs to the vehicle's suspension, over 100,000. A total of 1,570 miles is covered at speeds between 25 and 40 miles per hour. Another driving experience is gravel, 3,054 miles, to subject the underside of the body to stone chips, dirt, and grit. Cadillacs also make 2,160 passes through gritty water that tries to get into ball joints and other moving parts. Freeway-type driving is a total of 23,800 miles. At specified intervals, the driver stops the car and lets the engine idle, then turns the ignition off to simulate a stop in traffic or a full stop after highway driving. The city course simulates urban driving conditions with a lot of low-level accelerations and decelerations and low-speed driving under 30 miles an hour. A new Cadillac model travels this course 10,000 times. Another major area of the durability test schedule involves severe powertrain and braking applications on hills of varying steepness. Different throttle accelerations, including wide open, downshifted transmission, reversing, full brake stops, parking brake operation, thousands of maneuvers on the hills. Periodic severe driving procedures include locked brake stops on chatter bumps from 60 miles per hour, locked brake stops from reverse, a total of 360 times, extremely high stress forces generated on ball joints. The Seven Sisters course presents a variety of curve radiuses and road courses, some banked away from the normal direction. This course develops high lateral suspension forces. This procedure develops forces to the car's limit of tractive ability. Traveling at 50 miles per hour, the driver turns the steering wheel as far as it will go while still maintaining speed, 8 times right and left turns. Still another set of maneuvers generates high torques in the powertrain system. Using a tachometer to maintain 1,200 RPM, the driver shifts from park to reverse to drive to reverse to drive 30 times during the overall durability test schedule. For extreme hot weather testing, Cadillacs are taken to the GM Proving Ground in Arizona, and for extreme cold below minus 20 degrees, to the GM facility in Kapuskasing, Canada. Add high-altitude testing from GM's Pikes Peak, Colorado facility on mountain roads over 12,000 feet high, and you've got an overall durability test schedule that's about as close to the real world and real customers as you can get. It's a comprehensive schedule that exceeds the demands on the car caused by the toughest customers' driving habits. Throughout the durability test schedule, cars undergo periodic major inspections for such things as alignments, clearance changes, oil usage, structural integrity, brake wear. Some inspections, like checking the floor pan, involve the removal of other components to get to the one to be inspected. It's a thorough, time-consuming operation, following a detailed checklist, and technicians are often under pressure to get the car back into testing as soon as possible. Of course, the continuing daily input from the test drivers on all 3 shifts plays a major role during the durability test program. They document things that don't operate properly on the car in their reports, including subjective feelings about ride and handling, for example. And if there's a breakdown, the car is towed in immediately. In the case of electrical and electronic systems, drivers even have a tape recorder to document exactly what happens as it happens. It's up to the Liaison technicians to make sure they get all the details. Eric Trafton is typical of the Cadillac Proving Ground technicians. 10 years in a General Motors dealership, associate degree from a community college in automotive technology, working on an electrical engineering degree at Lawrence Institute of Technology in Southfield, Michigan.
The drivers don't always know all the technical aspects of a vehicle. There might be, it's like a lawyer when he says, give me all the details, because you don't know what's important sometimes, and so you need that. And they don't always know what's important, and sometimes they don't know how to explain it correctly. It's very important to get all the details that a driver might not write down on a driver report, so we can convey that message to the particular engineer involved in that particular part. A similarity between my job and a service advisor at a Cadillac dealership is that when you talk to a Cadillac customer regarding their car, you have to get all the details so you can convey that to the service technician to get the job repaired correctly, and that he'll know all the particulars to diagnose the situation.
Generally speaking, testing is continued until it is interrupted by a component breakdown. When that happens, the technician immediately contacts the appropriate Cadillac engineers and the engineers from the component manufacturing company. At times, they say, go ahead and fix it.
Other times, they may come up with an interim fix. For example, in one case, the driver reported the transmission's failure to shift properly.
Technician diagnosis showed that the intake hose between the air cleaner and the engine was collapsing, causing the symptoms. So, a wound spring was put in the hose to keep it from collapsing. Suppose a driver reports a loose front-end alignment, and inspection reveals a frame crack. The procedure here might be to weld straps on to bridge the crack, so testing can proceed on that car until a new frame is provided. This is the kind of fix sometimes required in durability testing, but never performed on a customer's car.
Maybe an engine mount breaks. You can repair it, or an engineer may decide to let it go as is to evaluate secondary problems that result. For example, the effectiveness of the safety retainer and what happens if that lets go. Technicians are involved in all kinds of fixes. Suppose the driver is getting ground contact of the oil pan and there's a sag in the mounts. Until updated parts arrive, you can shim up the transaxle mounts from the frame to get proper clearance.
Or maybe there's excessive road splash in the engine compartment, and technicians have to make wheelhouse shields, or skid plates have to be fabricated to put on frame cross members that are bumping the ground on dips. All of this temporary improvising is performed only to allow durability testing to continue. Machining, cutting, welding. Cadillac Proving Ground technicians do it all. Technicians use computerized torque wrenches, the same as used in the assembly plants, on fasteners, and make sure the same fasteners are put back after a repair. Torque is rechecked and reported to Cadillac engineers. This way, data can be developed on how many times fasteners can be reused.
In addition to identifying problem areas and verifying durability and reliability, the test programs also provide information used to develop new tools and service procedures. For example, a new ball joint removal tool was developed to press the tapered stud out of the steering knuckle, and a special offset box wrench to tighten the nut when replacing the stud.
In addition, a procedure was developed for approximating the factory's computer wrench torque on the nut with conventional hand tools. This is accomplished by making sure the stud is seated, then tightening a certain angular rotation beyond the initial torque, similar to spark plug torquing. On the 86 Sevilles and Eldorados, it was difficult to remove the shaft fastener for the engine motion dampener because the flat spot on the shaft wasn't high enough to get a wrench on it. So they elongated the flat spot to access the wrench. A lot of effort is concentrated on service procedures.
3 years ago in the 86 Eldorado, Riviera, and Tornado development on the durability testing, we didn't have the shop manuals, trouble trees. So we worked with the design engineers, and part of our job responsibility is to help him design that type of material for service work. The electronic diagnostics, the engine diagnostics, all that is developed in close relationship with the design people out here. As the car generations develop, we use the handwritten trouble trees and develop those to a point where they do get approved and printed and in the service type of form. Then we go ahead and verify those type of forms on our durability testing. For production vehicles on durability test, we handle them very similar to a dealership. The driver, a la customer, will come in with a complaint. It is written up like a serviceman, service desk writer would write up the complaint. All the documentation is there. It is given to a service technician who follows through with the investigation. It's all documented on paper. The service procedures are all used the same as service, and we follow through from start to finish exactly that way. We try to do that so that we can help the field service technician to make sure that things do get properly followed through, finished, and the right part is corrected. Our service technicians here do a variety of work. We not only follow all our durability vehicles, we also have them build our test fixtures for measurements, for making special tools for service and taking apart things. We also work on all our service vehicles, our tow trucks, we have piggyback trucks for transporting vehicles. We have a variety of equipment out here, instrumentation that they do repair. Communications is probably 80% of our job out here, either written for documenting problems and service procedures, as well as by phone. And it's very, very important that we don't lose any information. All the future test cars, test programs are all based on what we do out here, and it's very, very important.
During a vehicle's stage on durability test, many parts are changed, and it's very important to document the change, what else was disturbed in that area of that part during the change, so we can track part miles and the amount of times it was disturbed. That way we know if a fastener's been out 5 or 6 times or a part's been removed 2 or 3 times, and that could have a big effect on part durability.
When we run across a significant problem on durability, we document that with a GM intercommunication TIR, Test Incident Report paper. That is very important that the design engineer, wherever he may be in GM, gets the information on his part problem, failure, or procedure problem, and that he is made aware of that and can correct whatever problems are involved in as short a time as possible. The documentation on that piece of paper is our prime priority out here. Parts that are written up on a TIR are the hottest thing we have. We air freight, express ship that part back to the design engineer wherever he may be, in the United States, outside of the United States, but he gets that part just as fast as we can get it back to him. This communication from us to the design people is also circulated to other engineers throughout GM to make them aware that there are problems, and they can be aware in their programs they can make the same type of corrections. We're here to build a product that the customer can be very well satisfied with. And to do that, if you don't have the proper service procedures, you aren't going to do that. And our job is to make sure that the people in the field have those type of documentation, service manuals and procedures to use so that they can come up with the right answers. Our priority here is to build a perfect car if at all possible. And for the customer to be satisfied with this vehicle, we have to do our job. And finding the problems, documenting them, and getting them corrected is our priority. We don't want to have the customer doing our test work for us.
When a test schedule is completed on a new Cadillac model, technicians completely disassemble the car and all the parts and components are displayed for design engineers from Cadillac and from the component manufacturers. Each part is then sent to the relevant engineer. That's the story on durability testing of new Cadillac models. It's a long, tough process, and automotive technicians with a background like yours can help make that process work. The result is more reliable, durable Cadillacs for our owners. And then, as I said before, maintaining that quality is up to you. Remembering what we've just seen and the similarities to dealership procedures, what are some ways to help assure quality service? For example, how important is it to get the full story from the customer regarding his service problem? What are some ways to get this information from the customer? Why is it important to write this information down in detail on the work order for the technician working on the car? Why should the technician explain in detail on the work order what repairs he made on the car? Why is it important to explain to the customer what was done to the car? Discuss it. You may come up with some ideas for improved communications. The next roundtable meeting is going to take you aboard one of the most modern luxury liners afloat. You're going to see how technicians keep that ship and its huge diesel engines and equipment running smoothly, even though they're in port only about 8 hours out of each week. Talk about pressure to deliver service on time. They've got it. Because these passengers have high expectations. You've got the same kind of pressure and the same type of demanding customers. So you really will appreciate this shipboard professionalism. This is Joe Penberthy for your Cadillac Roundtable. We'll see you at the next meeting.